but it is Martez Reed. I am a principal field solutions developer at Puppet, hence the shirt. It'd be kind of weird if I worked for Red Hat or a chef. 10 years of IT experience with an automation focus. So a little bit about myself to not think that all the people that speak are people that have been in IT for years and years and just these great rock stars. IT person just like the rest of you all. A couple of ways to find me: LinkedIn, Twitter, GitHub. Being a automation focused person, got quite a few different projects and things on GitHub. It's a good place to find some interesting stuff. All right, so let's delve right into it. We're going to start with talking about CI/CD, a very used term. I come from a traditional operations system administration background. So I was desktop administrator, desktop tech, help desk, moved up into system administration, understood some things about networking, storage, virtualization. And then probably about 5 or 6 years ago, I was introduced to this thing called CI/CD. CI/CD, it's all you hear all the time now. And it was, of course, well, what is CI/CD? So the CI, continuous integration, basic way I tend to think about it and explain it is sort of the automated testing portion of the development of code. I am not a developer by nature. So for me, code was Puppet code, Ansible code. In this case now, a lot of people using Terraform, things like that. Since it is code, it can go through a CI/CD process as well. So that's where we would do the automated testing of syntax checking, linting, some of those standard validation, unit testing against the code itself. And then usually where I started to get confused when I first started was the CD part between continuous delivery and continuous deployment. So for me, continuous delivery is making sure that it is ready to go for essentially a human being to push this to production, whereas continuous deployment, that's taken out of the hands of the individuals, the human beings themselves, and is automated. So once you push it, it's out there into production. This is a chart or diagram that kind of explains a lot of that. And the one thing I will say is that oftentimes, as part of this process, is that we don't focus on a certain portion of the diagram. Go through unit testing, platform testing, staging, all of the lower level environment testing. And then we get to that section where it talks about right before deploy to production for continuous delivery. As I said, that's where the manual interaction comes into play. But for continuous deployment, it's automated. So it's automatically going through and not be gated. But what I would like to focus in on is this portion of the diagram that doesn't actually have a box. So this is usually one of the things that's not talked about is how do I get from here to actually getting it into production? And what are some of the things I need to think about as I go through that process? So in a lot of ways, I like to phrase it as this. Most people, when they're ready to hit that button and say, yes, I'm ready to go to production, usually what you're really deploying it into is more often than not sort of a black box of like, I think I know what production looks like right now, but I'm not really certain. And the anecdote that I like to use for this is imagine playing the game Frogger, those that are familiar with Frogger, but doing it with blinders on. So you can only see literally what's right above the frog. You can't see the trucks that are coming to the left, and you can't see them coming to the right. So essentially what you're doing is you're pushing the button that says, yes, go to production, and you're hoping that no truck comes and smacks your deployment, and you have to start all over again. So how do we do that? How do we gain back that visibility to see what's to the left of us and to the right of us? I propose we start to do that with environmental awareness. There are tools within our environment that we use every day for whether it's reporting, ticketing, log aggregation, just the environment itself that we're deploying to that contain a wealth of information that we can use to make intelligent and informed decisions about the deployment to production. And what this isn't to say you're going to gather all of the knowledge and all the information there is to ensure that your deployment is going to be successful. But what it will start to help you do is start to gain a better understanding of what that deployment looks like, and especially give you insight into when something breaks, it's not this sort of firestorm of like, oh, what happened? What's the issue? And you get into troubleshooting mode, and now you're not thinking very sanely, I would like to say most times. Some of you may be master troubleshooters and are completely calm and know exactly where to go and look for information. But I, on the other hand, tend to get a little flustered at times when troubleshooting an urgent issue. So one example of environmental awareness, as an example, if your CI/CD tool of choice happens to be Jenkins, being able to leverage that via a script or something to say, hey, I'm deploying to AWS. Let me make sure that the EC2 service is available for US East 1B in that particular availability zone, or just the overall US East 1, because nothing ever happens to US East. There's no outages there. But just to have that sanity check, because it becomes the case of you hit that deployment button and then like it comes back with this weird error that, hey, my application didn't do what I thought it was going to do. And now you're trying to figure out, is there something wrong with my code? Is there something wrong with our tool that's doing the deployment? Can it talk to the API? Is it firewall? Is it DNS? Because it's always DNS. So now you've spinning your wheels essentially and spending potentially hours and hours. Hopefully it doesn't take an hour or more, but it might, trying to troubleshoot what's going on. And maybe it was all along was, hey, something was going on in AWS with their US East region. So a number of different things that could potentially impact this is not an exhaustive list, but is really a starting point of some things just to really think about. Now, whether you actually craft these scripts or not, but really get to the point where you start to think about, okay, before I deploy to production, what's the status of these services that my application depends on? I do a lot of work with Terraform code, and oftentimes one of the things that happens is I'm standing up an EC2 instance and somebody's changed permissions on a KMS key that's used to encrypt a volume. And you go to deploy it, and all of a sudden, the instance doesn't stand up. It throws this weird error message. It doesn't say, hey, go look at the KMS key permissions. How many errors actually do that to point you exactly where you're supposed to be looking? Very few that I imagine. And so what this starts to do is starts to peel back some of the complexity of where do I at least start to look at IAM, KMS. These are just really the sort of the common sort of core components that most people leverage in AWS as an example. Another one might be, hey, I'm deploying my application. Are the security groups that I rely on, are they present within the environment? In a case of where you're starting to leverage infrastructure as code, Terraform, things like that, and I'm deploying, and potentially I'm relying upon another team to create these security groups within other environments, whether it's a security team or maybe a network team owns the particular security groups that I need to rely on. Simple checks like these help provide some of that additional information in terms of the success or failure of my deployment. Example might also be, kind of as I talked to, required security keys, certain VPC settings, maybe that I'm really relying upon in my application, being able to start to identify those and start to look at those as things I need to at least be able to call out, almost like a generated report before I use push a deployment to production that says, okay, yeah, essentially we ran all these checks and this is what the current status is. So once again, starting to decouple or demystify really what our environment looks like in production. This one is a sort of a non-purely technical one that we would often think about. This one I really like and really think is super helpful in the case of if Jira is used as your ticketing system, being able to leverage that as sort of the metadata hub of information. And in this case, we start to talk about sort of that cross team sort of collaboration. We're talking about DevOps, we're talking about working together, but no matter how much we work together, each different department or group within IT has a different role, a different responsibility. There's not this giant mind meld between every development team, every operations team, every security team. And then how can we potentially leverage a shared system that we're leveraging for this metadata? So information about the environment is often put into something like a Jira, to where is there an issue with the environment? As opposed to oftentimes me having to go ask somebody, hey, such and such application, I'm trying to deploy to production and it's not working. I'm getting this weird error message. Hey, did the security team or a network team make a change? Oh, yeah, we made a change to routing last night. And now the application that you tried to deploy doesn't work. What this tries to do is start to gain some of that environmental context of not relying upon our own minds to be able to conceptualize everything that's currently in production, but to really be able to allow computers to be able to enhance what we're able to keep in our own minds. So we can't keep all of the context there. In addition to that, I mean, ongoing maintenance, potential recent authentication issues to where your application can't authenticate. Hey, maybe somebody already filed a ticket that you could actually have used because you knew you were making another change that relied on some different piece of authentication outside of what's already there. And if you would have known that there was an open ticket that the authentication team was working on upgrading to a newer version prior to, you might have said, okay, let's pump the brakes on this push to production. In addition to that, one thing might be, especially for like those that are in e-commerce, being able to leverage metrics to say, okay, are we seeing more traffic than usual? Maybe there's something really weird going on. Maybe people are just now flocking to the site in droves, maybe 2x, 3x, 4x more than they would. And then you start to think to yourself, is this really the best time to push that new feature or that new version of the code? But without that information, you don't know. You figure, hey, it's a Tuesday. Now is as good of any to push that code to production and not understanding the potential ramification of, at this point in time, you're getting 10x, 20x the traffic that you would on any other day. And now that may potentially have a greater impact than it would have on a normal day. So in addition to that, starting to look at things also like database load. Is it higher at this point in time than normal? Maybe it's a shared database and another team pushed some code to production a day before your team did. And now the load on the database is much higher than it normally has been. And normally that would be perfectly fine, but maybe that increased load causes your application to run slower than it should. And then what often happens is you correlate the latest version of the code to the slowness, which may not actually be the case. So what happens is then you start to look at, okay, you need to inspect your code, make sure, oh, maybe I made this change that increased the database load, or maybe this is causing the slowness, maybe this is causing the slowness, when really you're just chasing your tail. In addition to that, I mean, things like leveraging Splunk. Are we seeing more errors than we usually are? And how can we start to leverage some of that data? So things like higher than normal log errors, higher than normal, or even potentially transient errors that may just be like blips, and we'll just associate it to a blip. So now that we've started to demystify pushing to production, this is kind of how I think of it. Hopefully the picture starts to get much clearer than just being this big black box. And so how can we start to leverage the insight that we now have about production to be able to gain greater insight based upon what we already know about the lower level environments? So in this particular case, we've got a bunch of errors going to Splunk. Sure, for everybody, this is pretty common. So especially, I like to use the example of Java because I've seen a number of Java applications that have been provided by vendors, being a sysadmin, and like, oh, there's something wrong with the appliance or whatever it might be. You start digging through the logs. Well, there's an error, there's an error, there's an error, there's an error. And it seems like this is normal. Everything was working when the rest of these errors are being thrown. So everything must look good. So how can we start to essentially play what we've got in pre-prod against what we got in production to be able to identify, yes, let's say in the case of version 1 of our code, error 101 and error 609 are sort of known error messages that get thrown, and like, application works perfectly fine, so we're not going to fix those. Nobody's ever done that. That never happens. So oftentimes, especially as a more junior person coming into the team, what often happens is like, oh, hey, I'm seeing this error message. What's going on? Then you talk to somebody more senior. Oh, yeah, don't worry about that. That's normal. And so what we've done is we've distorted what normal is. And so now we have to gain back that normal, we create a new normal based upon playing our current production environment data versus what we're seeing in the lower level environments. So in this case, error 933 gets thrown. And if we're relying upon the old normal instead of the new normal, oftentimes we're going to miss that error message that's being thrown, because we're going to say, okay, hey, we got 3 error messages. They're all lumped in there. And so that looks good to me. And you let it keep going. But in this case, it's a situation of now you're able to identify easily, like as on the diagram, hey, 933 is different. Let's investigate that a little bit further and see what's going on there, as opposed to being thrown off by the other error messages. And since I'm an infrastructure person, especially now that we've got all these great tools in the cloud and Terraform and CloudFormation and ARM templates, how can we start to leverage that information and sort of play those against one another to find out what may be different between our environments in terms of pre-prod as well as production? So especially in the case of larger organizations where code bases of Terraform are managed across different teams, this may not impact those that a single team owns all of the code in terms of the Terraform or the infrastructure as code for their environment. But for those that are in larger enterprise environments, this is, I'm sure, pretty common to where you've got different teams. And so how can we start to gain insights from these large code bases and be able to compare them to be able to say, hey, application, I know I'm deploying the application, but my application requires infrastructure provided by other teams. How can I, without asking them, hey, did you change something? Did you change something before you push to production, being able to take advantage of the infrastructure being as code and hopefully be able to identify any potential changes that have been made in the environment. And what it helps to provide is at least insight of a place to look. It's not the magic cure. It's not a magic bullet. It's a place to really start and help provide information. So kind of along this line, what you could start to do is during application deployment is essentially taking a snapshot of what the environment looks. So in this case, I'm using a ServiceNow, whatever tool it might be a database, it might be another CMDB product, and being able to stuff all that information in and being able to say, okay, this is what version 1.1 of my code looks like, as well as all of its dependencies, which are essentially it's the entire environment, or at least everything that the application needs to interact with. And as we start to move more and more towards codified everything as code, we can start to really take advantage of this to be able to say, okay, hey, I moved from 1.1 to 1.2 and something broke. Give me all of the changes for the environment between those two versions as a place to start to identify what happened. It may be something in the application. It may be something external to the application itself. But this starts to give a better insight into what can be used in terms of making that decision for deployments to production, so it's not a sort of a blind deployment. Kind of along the lines of gathering information, one of the other things that's been talked about and will be talked about in the next talk is chaos engineering. I know it's talked about in one of the security talks. In this case, it's sort of the more traditional chaos engineering, kind of as was stated, break stuff and figure out what caused it, and as well as what can be used to remediate the issue of what was broken. In more simple term, really it's a very scientific thing, but oftentimes we just conflate it to break stuff and hopefully see if your application is resilient. So for those that are not familiar with chaos engineering, here's an example using AWS. So in the case of load balancers and auto-scale groups, for those that are familiar, the thought is that I can create a resilient infrastructure, in this case with EC2 instances. My application is running on 2 instances in the auto-scale group. And so if I use a load balancer with an auto-scale group, and then if something happens to the EC2 instance, those that are familiar with the concept will know that hopefully the traffic will fail over to the other EC2 instance and start sending traffic there. That's always the hope. So this is what essentially chaos engineering is for, because it shouldn't be a hope. It should be something that you know for certain. So oftentimes it's things like invalid health checks that create an issue. It's also starting to look at the failover time of how long it takes to actually fail over the application. And so all this data is starting to be fed into how we're handling deployments. Additionally, things like issues with the EC2 instances that are underpinning it start to create issues potentially with the failover scenario. So these are the things that we're starting to test. So here are a number of sort of popular tools that are out there. Netflix's Simian Army. There's a open source project called Chaos Toolkit that provides chaos engineering. And then one of the other ones, which is a SaaS platform or SaaS solution, is Gremlin. So now we jump to machine learning, because what's a conference talk without machine learning or blockchain or artificial intelligence? I will only talk about machine learning. And I think this one really actually applies, not just to say machine learning, but in a lot of ways, a lot of the explanations I've heard about what is machine learning, what is machine learning, one of the explanations that I got was, in a lot of ways, especially for supervised machine learning, is a bunch of if-else statements is what machine learning is. But it's actually a very large portion of science. It's not just if-else statements. Two of the more general concepts around machine learning: supervised and unsupervised. Supervised being the one where we provide sort of essentially the answers to the machine beforehand about what to look for, as well as unsupervised learning, which the thought is that starts to bleed more towards the AI, where like the machine figures it out for us and is going to take all our jobs. Still waiting for that to happen. But in this particular case, it would be more towards the supervised learning, where we're starting to provide sort of the guardrails around what we want to look for our deployments. And so I talked about a bunch of data points and like, let's gather all the information. So how are we going to start to actually be able to leverage this? Because that's one of the things I've thought about is, as human beings, we can only hold so much information in our minds and only so much context around what the environment looks like. How can we actually really leverage machines to enhance what we're doing and not replace us, which is often what's touted as like, you're going to save all this time because the machine's going to replace you. You're not going to need to do anything. So in this example, it is being able to leverage all of the information that we've gathered, that we walked through the pre-production stuff, comparing those two, and actually gather that into sort of a single solution or a single platform that provides us insights about all of our different stages of the environment deployment, as well as the environments. So in this case, it's still a human approval, but even though it's a human approval, what we've now done is started to move from that black box of mystery of what production looks like to a more informed decision point around what choices we make in terms of deployments. So maybe it's a case of we've gathered the data, and maybe we're not going to deploy to production today. Maybe it's tomorrow because there's an outstanding issue with networking, or there's additional traffic that we're receiving on today, and today's not the best time to make this decision. And then maybe we start to step to a case of where we start to allow the machine to make decisions for us within certain guardrails to say, okay, these are the things that I want you to look for, and if it moves outside of these boundaries, then let me know. Otherwise, just deploy. And what this starts to do is it starts to provide that reassurance from the human perspective that, yes, the machine is making the decision, but essentially it's a decision that I've already pre-approved and within these certain bounds. Maybe it's a case of it never gets to, for some organizations, the point where the machine just where everything that gets pushed just automatically goes to production. And essentially what you're doing is, yes, you're creating another gate, but this one starts to be able to look at environmental data to make those decisions, as opposed to oftentimes the very arbitrary decisions of yes or no that we make without any actual insight into what the environment looks like and whether it'll actually be successful. And while the machine learning is helpful, when the organization potentially starts to get to a larger number of deployments, let's say per day or per week, then this can potentially start to move from, I believe, just the machine learning, machine approval to potentially the AI. I know I wasn't going to talk about the AI, but I do think that's definitely something that is potentially possible, but only I think after we've gone through some of this machine approval process and understanding, yes, the machine is doing exactly what I've said it should be doing within the normal guardrails. Thank you for your time. My name is Martez Reed. A bunch of different ways to find me.